Friends, welcome to my YouTube channel. Dinesh here. This is the 20th video on natural language processing. In this video, I am going to discuss an implementation for automatic text generation. We have done many implementations like sentimental analysis, chatbot we have done, text summarization we have done. This is automatic text generation. Even in the NLP playlist, you can see videos on speech recognition and NLU, natural language understanding, and the implementation for speech recognition is also included in the same playlist. You can watch those videos. See, automatic text generation, there is a huge amount of data that can be categorized as sequential. Sequential means the current data depends on the historic data. That's we call it as a sequential data. It's present in the form of audio, video, text, time series, sensor data, etc. When handling text, a model may be trained to make very accurate predictions using the sequences that have occurred previously. But one wrong prediction has the potential to make the entire sentence meaningless. See, normally RNN, that is recurrent neural networks, we use to process sequential data or historic data. A recurrent neural network is a solution for handling sequential data. But there are two drawbacks. That is vanishing gradient and exploding gradient. You can watch the videos for recurrent neural networks. It's a separate playlist for RNN is there. You can watch those videos. So these are all the two drawbacks of RNN. To rectify these drawbacks, the solution for these drawbacks is LSTM, long short-term memory, and GREs, gated recurrent unit. In this implementation, we are using LSTM. Say for this word prediction or the text generation, we are using LSTMs. What are the different steps of text generation? That is importing dependencies, loading the data, creating character word mappings, data pre-processing, modeling, and generating the text. Now the softwares we use, I am using Tensorflow 2.2, Keras I am using, Python I am using, Anaconda, and Google Colab. This is another interesting tool, and Spider also I am using. Google Colab, I think I am going to give some idea on Google Colab. See, Google Colab is a free cloud service and it now supports free GPU. That's very important. You can improve your Python programming language coding skills, develop deep learning applications using popular libraries such as Keras, TensorFlow, because it supports, it provides free GPU. That is the one advantage about. Let's get into the implementation part. For that, what I can tell you is I will give you some idea about Google Colab. So this is a Google Colab. See, to get Google Colab, what you can do is you can type Colab here. Then I'm giving some idea about Colab. It's a very interesting tool. See, this is colab.research.google.com. You type that URL. Then you will get this window. Then you can get into the new notebook. Then you will get this one. That is the Google Colab. It's built on top of Jupyter Notebook. It's the same as Jupyter Notebook. What difference you want to make it here is you want to change the runtime. You have to click on runtime and change runtime type to GPU. Then save it. That's the one thing you need to do. After that, just click on connect. It will connect. This is the way you can do. Then now it's connecting, it's initializing, and you will get a green tick mark. See the RAM and disk you can see here. So this is the this is the cell. Here you can type, see, print Same as your Jupyter notebook. Print hello. I am printing it, and you are running it. You are clicking here. Now it will run, and you get the output. So this is a simple introduction to Google Colab. The advantage of Google Colab is like you can get extra RAM. If your program, if you are training a model, you need RAM more than. Now you are provided with 13 GB. Now you have in this you have 13 GB of RAM. Sorry, yeah, right. If you want more RAM, then you can it will ask for more RAM. When you are training a model, if you want extra RAM, then this Colab will ask, and then you give S, then the X more RAM you will get it. That's the advantage of this wonderful tool, Google Colab. So for training machine learning models, this tool is very useful. See, let's get into this program, our text generation program. See, I have the program here. This is the word predict. This is the program I am using here. I will show you. I will copy this code and I will run it in the Google Colab, so you will understand it. Say first I will copy it from here. It's nothing complex. It's very easy. I am using, as I told, the softwares I am using are here. We discussed, right? I am using Tensorflow, Keras, Python, Anaconda, and we are using LSTM. In this implementation, we are using LSTM. We discussed that. Fine, good. Now we will get into the implementation part. I am just copying the code from the spider ID. It's along with the Anaconda. You will get it. This is the spider ID. This is what I am going to. Let me try to run it in the Colab. Otherwise, we will get into the Jupyter notebook. But we need Colab. Then only we can, because this to train the model we need. I will open a new shell. You can click on code and you can get a new cell. See, here I am importing TensorFlow. And import string, import request, and this is the URL I am using. This URL you need to understand. This is a play written by Shakespeare, William Shakespeare. Sonnet is the play. When you click this, when you copy this link and paste it on the browser, you will get that play Sonnet. It's a huge amount of text is there. So I will show you how we will let's run this piece of code. Let's see what's happening. See, this is the 100th e-text file presented by Project Gutenberg. See, I am printing the length of the data and the first. See, I am getting the data here. Data response.text.split, and this data 0. This line of code, you can see it. This is the print data 0 that is printed here, and this is the length of the data. This is this one. It is the total this much length. It is length of the data. If you want to see this URL, I can show you. It's a huge amount of text is there in this. I will show you here. It is yeah, you can see this is the Shakespeare. This text, it is so see, it is starting from, this is the 100th text file presented by Project Gutenberg. That's what we have seen it here. See, you can see it here. That's what we have. It's the first part. So this is a very huge one. It will go like anything. This play, the sonnet, this is the play is sonnet written by William Shakespeare, and we are using this for the text generation. So we will text generation means For example, if I am telling, what's one example? I can tell you text generation means he is going to, then we can fill different words like school, or he is going to office, or different words we can fill it. So how we will predict this word school or in office? So what here we are doing is we are analyzing the program the application will study. Here we are using LSTM, long short term memory, to, and these are all sequential data, so we can't use recurrent neural networks, the drawbacks I have told. So we are using LSTMs and we are using to predict this data. You understood? So we will give, see for example, we will give a sentence from this part and we will ask our application to predict the next piece. That's what we do here. You understood? Now I'm going to cleaning the data. As part of NLP life cycle, cleaning the data is an important process we need to do. I'm going to clean the data. So that's what we are doing it here. Just we will do it in the Colab. It's very easy. See, it's here. I will open a new cell and I will run it here. I am going to run it. So here tokens, in this we are having a for loop, and we are the tokens, it is all the tokens are returned from this method, clean underscore text. That's what we have done it here. You understood? Now the next part, we can if you want, we can print the length of the tokens as well. It will give all these the 50th this colon 50, that also you can see here. So in the new cell we can run that. This is Google Colab. It's a fantastic tool. You can here see, you can see the print tokens colon 50. So the length of the tokens, everything it's giving. It's this is what we have done so far. Now what I am trying to do is, in the next part here, now the special characters as part of NLP project, the special characters and punctuations is to be removed. To get the unique word, we pass it in a set, and this will be the vector. So for that we will run this print. If you want to see this, if you run it, you can see here it is the set, the length of the set, it is 29511. You understood? Now we will be using a set of words to predict the next word. In this example we will be using 50 words to predict the next word. We will we are using 50 words to predict the next word. Here the first 50 is the input to the model, and another word is the output. So that's what we are taking. Length is equal to 50 plus 1, and length lines is an array. So these two we are doing, and we are writing this for loop. I will explain you what exactly I am doing it here. We will open a see, we will connect it. We are connected to GPU but not utilizing the GPU. Okay, connected to hosted runtime. Okay, fine. Change the runtime type. See, we are connected to GPU. Fine. So we will use the next this one. So length, you understood this 50 plus 1. 50 is the input. You can consider like that. This one is the output here because we are using the previous 50 words to predict the next word. So here for I in range, length and length of tokens, then sequence is equal to tokens I minus length colon I. Then we will append all these lines. If I is greater than this number, we will give a break. So let's run it and see it. Here we are not expecting any output. We just run this code in that cell. After that, what we are from the spider, if you want, you can see the length of the lines of the all these things. You can print it. You can see it if you want. I can show you all these things. You can print it. It will give you the result. Then you will get more clarity there. This is 1 second. I'm typing it here. So this hash we need to remove, delete. I think print is not needed in this Colab. Let me run it. Is it giving the output? Yeah, it's giving. See, length of the lines it's giving, line 0 it's giving, the tokens it's giving, every result it's giving here. You can see it here. See, it's all the results it's giving. We will take the next cell, and now what we are going to do is we are building the LSTM model and prepare x and y. So LSTM, long short-term memory. I already explained you why we are using LSTM. I am going to import the necessary libraries first. You may be familiar with these libraries. I'm going to import all these necessary libraries here. Let me copy it. See, NumPy I am using. Tensorflow.keras.preprocessing.text import tokenizer. Sequential, dense, LSTM, embedding, pad underscore sequences. All these things I am importing from Keras. See the softwares I am using are, I have installed Anaconda. Python is part of that. On top of that, I have installed TensorFlow 2.2 version, and then I installed Keras. So that's the way I installed the softwares here, and now I can just run it. So this will be imported. So it's done. Now we will get into the next code and see here we have this thing. You can see here I have the tokenizer. I am creating a tokenizer and fit underscore on underscore test. That method I am passing the lines, right? See sequences, it is tokenizer dot again text underscore 2 underscore sequences. There also I am passing lines. After that np dot array, there I am passing this sequences. Then I will get x comma y sentences colon this sequences colon and colon -1. So this piece of code I am executing. Let me run this code. It's let me see whether it's working. because in the spider it was working. Why I am using it in the Google Colab? Because I cannot you know train the model by using the spider or in the local machine. I need a Colab for we need extra RAM. That's why I am running all these things in the Colab. Now if you want, if you see these things, you can see here, we will print those things as well. And I'm removing this hash because there it was commented. Fine, let me run this. See, you can see the x0, y0, it's there. And vocabulary dot size, that is the length of the tokenizer dot word index, and y is equal to 2 underscore categorical. There I have passed the y comma number underscore classes equal to vocabulary dot underscore size, and the sequence underscore length is also calculated here. So now we will get the next cell and try to run the next part of this code. So next is the LSTM model. We are trying to create the LSTM model and we are trying to train the model. See here we need to need extra memory. The one thing, if we are lucky, because last time I could able to train it by connecting to the extra memory. I'm not sure whether I can do it. Sometimes it may be busy, but if you are not able to do see, if I'm not able to do it, you can try in the same process. You can try it in your system and see now itself the RAM is almost full. See here you can see here it is the color, see it is almost full. Let me see whether it's giving extra RAM. It depends, sometimes it may be busy. If we are lucky, we can train the model now. Otherwise, when you are doing it, you can the same process, you can repeat it and you can try it from your end. The code is working fine, perfectly. See, this is here you can see the sequential model for LSTM. We are adding the embedding and add LSTM here. 100 return underscore sequences is true. LSTM here the dense layer we have added. The activation layer, it is ReLU is the rectified linear unit. See, you need to understand what is a neural network and what is ReLU layer, rectified linear unit. And here we are different activation functions are there, right? ReLU, softmax, sigmoid, there are different activation functions are there. Here we are using the dense layer. Here we are using the ReLU, rectified linear unit, and here we are using softmax is the activation function. The reason is softmax, gives the probability between 0 and 1. So softmax activation function. So if you have doubt in these aspects, you can because here I am not explaining. We have separate videos for activation functions and neural networks, or recurrent neural networks, convoluted neural networks, so you can watch that. See, model.summary. After that, we are compiling the model. You are using the categorical cross entropy loss function, the ADAM optimizer, and matrix is equal to accuracy. Model.fit x comma y, we have epochs I have given 100 and the batch size of 256. Let me try to run this model. I'm not sure. I'm sorry for that. Sometimes this is Colab will be busy and it won't connect. So if we are lucky, we can run it. Let us see if it is, because it will, this is the way for you will also get it. It will tell them it is going to crash and we will give extra memory like that. Normally we will get the message. but I want to see. See, it is giving extra. See, you can see the message. Your session crashed, automatically restarting. After that, oh, your session crashed. Oh, your session crashed after using all available RAM. Sorry, it's not connecting at this point of time. It has to ask, we will connect to the we will give extra RAM. That message sometimes it will give. See, I'm not getting, sorry for that. See, you can run this, you can use this Google Colab and you can run it. If it is getting, it will train the model. See, here you can see everything, it's working fine. Model sequential. See, once it is started with the first epoch, it's crashed, the system is crashed. It's fine. See, what I will do, what I will do is I will show you the method to, after this training the model, to predict the next test. I have written this method, this function, to predict the text. This is the function. See, I will explain you the code as well, so you can try it in your machine. So I'm not lucky enough to connect to the, because last time it was connecting in my Colab and I could get an accuracy of around 70 percentage, and it was predicting as well, but now it is not doing it. See, let me show you the method. To after that you can use this method. This is the method I have written. After training, you need to run this method, generate underscore text underscore sequence. Here I am passing the model, tokenizer, text underscore sequence underscore length, and seed text and n underscore words. So this is array. The text, it's an array. C4 here underscore in range n, this in this range I am passing the n underscore words. The encoded is equal to tokenizer dot text underscore 2 underscore sequence. Here again I am passing the seed underscore text. Here I am using the encoded pad underscore sequences because we have from the LSTM. You may be familiar with the padding and the recurrent neural networks and convoluted neural networks. You may be familiar with what is padding and what is the stride. So these aspects here, so that's what padding is. Here we are importing the pad underscore sequences. So I am passing that thing. See, I am doing that pad underscore sequences. It is encoded, that is max length is equal to text underscore sequence underscore length. Truncating is equal to pre. See, y underscore predict, that is equal to model dot predict underscore classes encoded. See, predicted underscore word, I have this. Then I am running a for loop. The here word comma index in tokenizer dot word underscore index dot items. Then if index is equal to y underscore predict, predicted word is equal to word. Then break. Then seed underscore text is equal to seed underscore text plus predicted word. Then text dot append predicted word. Then return the text. See, this generate underscore text underscore sequence. Then this will we are calling the method, and after that you can print the seed underscore text. That is the next see, print, yeah, right, seed underscore text. So here you can print this, that is the predictor, that is your prediction. So here we couldn't train the model because I passed a huge amount of, see, you have seen it, this much amount of data I have passed. We cannot run this, train the model in the local system. We need a Colab, Google Colab. That's what I have shown you, how the Google Colab works. What is Google Colab? But I was unlucky. See, I couldn't because previously I could run it and train the model, but now it's not giving the extra memory to train it. Let me try it once again. We were running this cell only, right? Yeah, this is the cell. Let me run it once again. Let me try to train the model. Let me see what it will happen. So it don't again we need to run it once again. That's what. Fine. See, we are not I'm not wasting the time as well. See, this method you understood. After training the model, you can call this method. When you run this method, what you will do is what you will you can here again we are getting the error because we couldn't train the model, and we are not able to run it if we want to start. Otherwise we have to run this one. We need to run it runs from the we have to start from the beginning. This we need to run it. After that we have to call this cell. We can run it. Then you have this one. I want to see whether I can get the extra RAM. Let me see it. And you have this piece of code, right? This also fine. This is it's running. Yeah, it's giving now this. That's also fine. Now if you try to run this, it's imported all the libraries. Now here you have the tokenizer. It's fine. It's running. Now we can use this. Okay, it's giving the result. Yeah, it's taking, you can see here it taking extra RAM. Now we are going to train the model. Here only we need to get only 13 we have RAM. We need around 25 30. That Colab usually give the extra RAM, but now I'm not able to get it. That's what I previously I was able to run it and train it, but now again let's see whether it's running. Or see, your session crashed, automatically restarting. After that only it will ask whether you need extra RAM. Oh, after a crash, okay, your session crashed. It's not asking for the extra RAM. Sometimes it will ask. Even see, after that what you need to do is you need to call this method. You need to get the extra RAM. You need to train the model. I'm not able to do it here now, sorry for that. After that you can run this method. Then it will give the prediction. Here we couldn't train the model properly, so that's what I'm getting the error here. We didn't train the model. So this is the method, you can use it. So that's all I can explain you, because the Colab it's not connecting. Google Colab it's not connecting properly, sorry for that. Anyway, thanks for watching. Please like, share and subscribe. Thanks a lot.